Hello, everyone, and welcome to the AI Genius series. I am Priyanka Vergadia. I am your host for today. I lead our developer engagement strategy. And last time you were greeted by Vinayak. He is my co host for the series. We are really excited to get you all going with AI. So, this series is a set of 6 sessions. If you joined us last time, we explored our models, the large language model, small language model, and some decision making around that with Vinayak. If you haven't catched that, I highly encourage you to go back and watch that session if this is your first time here. And today we are going to get into production ready RAG with Azure AI Search. And before we talk more about that session, there's 4 more after that. We're going to talk all about agents. Then on 18th Feb, we will talk about multi-agent systems and how to build them using Azure. And on 25th Feb, we will actually create a cloud native infrastructure using we will create an intelligent app using our cloud native infrastructure. So we'll show you how to do that. And then on 4th March, you're going to learn using Copilot, how do you build an application and then deploy that application into Azure. So there's a lot of amazing content, and we try to create a package that would give you a flavor of pretty much everything that you need to know in order to start building AI applications, all the way from making your model choices to modifying the models to do RAG and make it adaptable to your applications. All the buzzwords around agents, but actually distilling it down to what you should care about when you build AI agents, multi-agents, GitHub Copilot. We're really trying to cover as much as we can to give you the entire flavor and the lay of the land to be an amazing AI application developer. With that, the last session is actually really amazing. It's not even listed on here. You will actually get to do all of this is as a part of a hackathon, and we will give you access to the Azure credits and the platform, and it'll be gamified. So you'll have opportunities to actually create some of these things that we are teaching you in the next 6 weeks, and show off your learnings. You get badges that you can post on LinkedIn, and lots of opportunities to win awards and learn and have fun along the way. So I'm very excited for how this culminates into an actual hands-on learning experience. So encourage you to, as you go through these sessions, if you give it a try, all the sessions have GitHub repositories associated with them, and we are sharing them as resources. So I highly encourage you to try those out as you go, because that last session is going to be your opportunity to show everything off and to win some awards and show it off on LinkedIn as well. With that, if you haven't already registered for the rest of the sessions, the QR code up here is going to take you to the registration page. Sign up for all of them just so you don't miss them and you get reminded to attend them. And with that, I'm going to pass it on to Anthony Shaw today. He's going to take us through production ready RAG with Azure AI Search. Off to you, Anthony.
Thanks very much, Priyanka. Hey, everybody. My name is Anthony, and I'm speaking to you today from a very hot Sydney. We're in the middle of summer here, and it's pretty hot today. And it's been quite the crazy few weeks in the world of AI. I'm just going to kind of bring you through production-ready RAG and what that means, and talk about Azure AI Search as well. This talk kind of includes a number of different demos to kind of show the RAG pattern. And the thing that makes it production ready is we're going to talk about this particular sample, this demo project that we started, I think about 1.5 years it's been now. We've been working on this. It was just an initial sort of proof of concept demo that we shared with a few customers. And it's been our most popular sample that we've ever put together. and it's used by some of our biggest customers around the world. And what that means is that they've put it into production and they've given us feedback about what they want improved, what they want changed, and all that kind of learning from those customers has come back into both this presentation and into the demo itself. So what we're going to be looking at today is the idea of retrieval augmented generation, which is a sort of really fancy sounding term for something that's really quite straightforward, which is just finding some relevant data and then copying and pasting it into a prompt. In this session, you did the last session you did, where it talks about LLMs and SLMs and different models. Really, it's kind of about extending the behavior of the model. So I'll explain what that is and what it means. RAG wouldn't be RAG without vectors and vector search and vector databases and vector stores. We're going to talk about all of those different topics. We're going to talk about what state-of-the-art retrieval is and what AI search can do with retrieval. And I'm going to give you that kind of context with some examples of questions and answers, which some types of vector search algorithms would struggle with, and what the retrieval mechanism that we have can do. We'll talk about data ingestion, evaluation, and then productionizing, and some finally kind of end with some Q&A. So kind of let's get stuck into this idea of RAG. So in the LLM talk last week, you'll have been shown large language models and how they're really capable of taking either information in their training set, which is, well, depending on which AI LLM you're using, that could be a few months old, it could be 6 months old, it could be a year old, or maybe even longer. Taking the information that it's got in its training set and then kind of predicting the response to the question that you've asked it. And this is what LLMs are excellent at. You give it a prompt and a behavior that you want it to have. You give it a question or you talk to it, and it, based on its training and based on how it thinks it wants you to respond, it will give you capability, but they're really kind of frozen in time. And LLMs, as well, data really, any kind of question you ask it, especially if you work in technology. So I lead the Python advocacy team. People have been asking me about AI models. My answers probably changed 10 times in the last week. So it's not really great to have an LLM that only knows about things that happened 6 months ago. So what we have to do with RAG is essentially kind of fix this problem. So this is outdated public knowledge. And also this particular demo, this model that we have, it works on internal data. So if you ask an LLM about travel plans in popular cities, stuff like that, it's great. It can give you some ideas. But if you want to ask it about your internal procedures, if you want to train it on all of your products, for example, if you're like a manufacturing company and you build products, and you want an LLM that's able to talk knowledgeably about your products or help with support requests, you kind of have to train the LLM to be able to do that. And there's 3 ways of doing that. So to give the LLM additional knowledge beyond what's in its original model. So the way I like to think about the LLM's model is it is frozen. It's like a huge kind of ice cube. You can't
I think Anthony is just frozen for a minute, folk. So Priyanka might feel some time while we check on him.
Yeah. Okay. So I thought it's just for me, but because I'm having internet issues here at my end too. But as long as I'm appearing, let's talk a little bit about the incorporating domain knowledge, right? There are 3 ways to do that, honestly, in LLMs. And the first is prompt engineering, right? Where you're able to, I think his presentation disappeared too, but as long as I'm appearing, I can talk you through the three options. The first is prompt engineering. This is where you're able to provide context to the model, which means all of us have been using some sort of chat interface like ChatGPT or Copilots today, right? When you do that, when you offer it the PDF or a long context where you say, this is what I'm looking for, and here's the additional context that you should be aware of. And so based on that, generate something, right? That is that in context learning. But the problem with that is you only have a certain amount of in context memory. And that leads to errors like you have run out of context window, right? I'm sure you all have seen those errors when it's like the prompt is too big, the LLM cannot really handle it. That's because all LLMs have context window limitations and capabilities on the number of words or whatever that memory size is, right? So fine-tuning is one of the other ways in which we modify or tune LLMs such that they can provide you the responses that are specific to the type of context that your business needs. And in the fine-tuning case, you actually are editing the model itself to and providing it examples of the prompts and responses. And these are high quality prompts and responses that you will give to the model to learn from that context. And so now your prompt itself does not have to have that context because you've trained it or fine-tuned it, which is usually instruction tuning. And instruction tuning is what I just described, which is giving the prompts and the responses, the expected response. And you can literally do this in like just thousands of examples. You actually don't even have to give too many examples. So you take a base model and then you provide these additional prompts and response pairs that are high quality in nature, most likely human written, and then your model is then tuned again with that data, with that additional data, and that is the fine tuning. That the resulting model is now able to answer questions that are similar to the examples that you provided it while fine tuning, which means that, if, for example, if you had medical use cases, if you had specific product use cases, all of that you provided it as in the fine-tuning data set. So now the user does not have to put that context in the prompt. And so it becomes more specific to your use case. That's the second option that he had on screen. And then the third one is RAG. And RAG, which is Retrieval Augmented Generation, applies to real-time use cases. So this is when you already have the model, and now but by real time, it means inference time as well. So at that time, when you're giving responses to the user, the model itself is, let's say, fine-tuned or may not be fine-tuned. It does not matter, right? You have some model that is either fine-tuned or base model. We don't care. That model is given a prompt from the user. Now, with RAG, what we're going to do is in real time, when the user has asked the question, we are going out of that model. There is the orchestration layer in the middle, which I'm sure Anthony is going to talk about. But that orchestration layer then sends the request to internal documentation and data sets in vector store and searches through the embeddings, and then able to retrieve information off of the documentation and databases in real time and respond to the user, combining the response with the large language model and the retrieved information in real time. And both of those things combined then goes through the LLM. The LLM generates the response and then sends it to the user. So those are the three different options that we have when it comes to modifying the large language model to serve the use case that you want to serve. Most likely, you are going to use some combination of fine-tuning and RAG when you are creating a use case. And you're able to do all of this inside Azure AI Search. And I don't know if Anthony is back.
He's not back just yet. Apparently, he must be experiencing some pretty bad technical challenges. So apologies, everyone who's with us today.
Okay, because I don't have the next slide.
No.
Otherwise, I would progress further and go into it.
No, I've chasing that as well. So we apologize as well.
Apologies, everybody, but we will get back to it in a few minutes here.
Just bear with us. Okay, I have a deck which I will share, and maybe Priyanka, I'll just drive as you talk, and we'll see where we land. Okay.
All right, let's do this. All right, guys, I'm flying blind. I haven't seen these slides, so we are going to have fun.
All right, let's try this.
But hopefully I will guide you all in the right direction. Cool. I'm not seeing anything yet, but let's see.
Not seeing anything. Adding to stage. Okay, now it may not be the perfect way to show this, but I'm trying to work off one screen. Can you at least see that?
Yep, I see it now. We were on this slide, and I've already talked about the difference between all these options. So let's go to the next one.
Okay.
Great. I would do the whole thing. Yeah, great. So Retrieval Augmented Generation, I kind of touched on this, so maybe we don't have to do it again, but here we go, right? This is an example. What's the best shoe for hiking? The user asked this question. The search happens in the background to find out the different information sources that the company might have on these shoes. There might be stuff in the inventory. There might be stuff related to the product descriptions that might be coming from different places. There might be recommendations somewhere sitting as well. So you take all of that, and that comes through in search, and then that information combined with the large language model, and then large language model generates the response, and then you give the response to the user that the hiking shoes or whatever text. That's a combination of those two. Looks like Anthony is.
It looks like Anthony has returned. Priyanka, you've done a fabulous job. So I will remove.
I will pass it back to you, and we did these two slides, so you can move further.
Okay, thank you so much. Yeah, sorry about that. Australia's internet's held together with string and sticky tape, and it must have snapped somewhere. So, yeah, thank you, Priyanka, for covering there. So she was kind of talking about retrieval augmentation and how you can give extra information to the AI at the time in which you want to. The question is asked. So we have a demo of that up and running. This demo is for Postgres. This isn't using Azure AI Search. This is using Azure OpenAI with flexible server and contain apps. This is a really basic RAG demo. And what we're doing in this demo is basically showing you what is available and kind of what we talked about there, which is the user asks a question about shoes and hiking. We then look in the database inside Postgres. We find the most relevant result. We copy and paste that result to the LLM along with the original question. And then the LLM gives a really knowledgeable answer back. So I've got that running here. So we ask it, let me clear the chat and give you some options. So we can say, what is the best shoe for hiking? What climbing gear do you have that's cheaper than $30? And what waterproof camping gear do you have? So we can ask it, what climbing gear do you have that's cheaper than $30? if there are any rock climbers on the video, I strongly recommend that price point is not your your search criteria with climbing gear. You don't want cheap climbing gear because it can be quite dangerous, but they're giving you a nice sensible answer, which is, okay, there's a bag where you can put your chalk. We don't give you any cheap harnesses, but we've got some chalk bags. And it's basically use that question, and we can click on this icon here, and it will give us the thought process. So in this demo, we've taken the user's question, which is what climbing gear is cheaper than $30. We've then done a vector search by looking at some things. So we've basically taken the original question that's come back from the user, and then we've determined what things should we filter on in the database. And we've used a function in GPT-4o Mini. In this case, we've said, okay, it's come back and suggested that we look at the price column in the database, and we look at a comparison which is less than and the value is 30. Based on that, we've got these results in the database. So this is like product 1 and product 2. And then we've copied and pasted that product information into the prompt along with the original question. And we've told GPT-4o, your assistant that helps customers find out information about products. Respond as if you're a salesperson helping a customer in a store. Don't respond with tables. Only answer with the product details listed in the product. So this is really important. So if you have a RAG demo, the last thing you want is for a customer to ask a question, what climbing gear do you have that's cheaper than $30? And it comes back and says, oh, we've got the super deluxe climbing harness, which is available for only $10. And it's kind of hallucinated that information. So the last thing you want is for a simulator, like a bot like this, a chat interface, to be making up information. So in the prompt, you say, only use the information I provide below, and then you copy and paste the information from the search results from the database back, and you turn your temperature, which is kind of this, I guess I'd like to call it the spiciness of the LLM, like how random it can be. You turn that right down to be sort of a very boring LLM and only go with the facts and the information that I give you, so it doesn't get too creative and start making up products that don't exist or making up price points which are completely incorrect. So it's come back with a nice relevant answer, which is brilliant. And this is something which is available in Postgres. In the slide as well, we've got a link at the bottom, this one here. So akka.ms/rag Postgres is the source code for that demo. You can run that on Azure Container Apps. And the cool thing about this demo as well is we show you the whole process to do the retrieval stage, how to find information in a database, and how to give it to the LLM. So that's kind of like our most basic demo. Now, the next step, I guess, in improving RAG is when a user asks a question, it won't necessarily be in a nice format for you to do a quick search on. And I'll give you some examples here. So what's a good shoe for a mountain trail? So the really observant people maybe in the audience might notice there's a spelling mistake there. Mountain trail is spelt wrong. Another example is users can ask questions in different languages. And let's say that your product database is only in English, or it's only in Hindi, or it's only in French, for example, and they ask a question in a different language. Then how does it know how to search for the key bits of information? And what query rewriting is an additional LLM step that we put between the question and the search. And the prompt we give the LLM for this query rewriting step is, the user's asked the question, can you turn this question into a series of keywords that we can use to do a search on? So it's looked at the question, it said, okay, the keywords are mountain trail shoe, and it's fixed the spelling mistake, which is really important. So the LLM is smart enough, and it's seen enough spelling mistakes in its time to be able to correct people's spelling errors. You can also do, which we do in our demo, we can say, if the user asks a question which is not in English, I want you to give me the keywords in English. So if it asks the question, you know, what's a good shoe for a mountain trail, and they ask that in French, it will still give me the keywords mountain trail shoe in English, so that when I do a search on the database, it's still going to come back with the English results. So this additional step is where we put an LLM in between the question and the search. So what we end up with is 2 LLM calls. And something I guess we've kind of evolved over the last year is when we originally put this idea together, we were using typically the same base model for both LLM stages. Nowadays, I would recommend using GPT-4o Mini, the mini model, for the query rewriting step. It's very fast and it's very cheap, and it's very efficient at doing query rewriting. It doesn't need to be a nice, complicated, fancy model to do this initial query rewriting stage. If you're doing this, you can use a small model, and you can use a small vector size in the output as well. So we kind of recommend using 4o Mini for the first one, and then when you look at the actual the final sort of answer, that's where you can get a bit more creative and experiment with different models. So it's going to come back and give me our answer. So we've got that same thing in the original demo, but we have that in the thought process. I kind of showed bits and pieces of that before. We were doing tool calls instead to work out the column filters. But yeah, you can toggle with that feature in that demo I talked about before with Postgres. So that's where we have a database, which is great. But when we talk to a lot of our customers, not all of their information is structured. It's not all in a relational database where they can just do a search. So for example, one of our kind of demos we like to do a lot is talking about an internal set of documents which have got information about health insurance policies or HR policies or like internal information that only you would know as an employee or as a manager inside the company. And a user, which in this case is an employee, asks a question like, do my company perks cover underwater activities? And this is an interesting question because it's kind of vague. It doesn't say which underwater activities. They're just saying underwater activities in general. And in our sort of PDF document, we've got a section in the PDF which says in the perks, it does include scuba diving, and it mentions some other water activities like surfing, but it talks about scuba diving specifically. Now, when you're working on this, this is kind of not looking for keywords. So I talked about query rewriting, where the LLM takes the question and gives you the keywords, and then you look for that bit of text in the database. This is where we need to be a bit smarter, and we need to kind of be fuzzy with our search. So yes, scuba diving is an underwater activity, but if we just looked for the words underwater activities in that document, it wouldn't come up with any matches. And this is kind of where you can be, LLMs can only go so far into solving the RAG kind of implementation. We need to introduce another technology. So the way that we do that, and I'll show you this actually as a live demo, and we're going to keep coming back to this demo because it is pretty capable and it can do a lot. If I say what is included in my Health Plus plan that is not in standard, and we've trained this LLM, basically just given it a lot of documents, and it knows and it can read through and search through these documents. And what we've given it is basically the ability to do like a fuzzy search. So it finds information which is similar looking to what I've asked for. And based on the sentiment of my question, it's not just using keywords, it's actually looking for relevant information. So for example, it comes back with your Health Plus plan includes coverage for emergency services, and it's also slightly different compared to a different plan. So it's kind of looked in and found in this PDF on the third page, there's some relevant information based on what you've asked for. And we think this is important and it should answer the question. So that's page 2, page 3, here we go. So it said, here's the plan. It says what it offers, and it's basically found that information in the document and given it back to me. Now, in the database demo, I was just doing a search where it would find a row in a database, and I'd copy and paste the row from the database into the LLM. We can't do that with this example because I can't just copy and paste the whole PDF into the LLM prompt for a number of reasons, which I'll get back to in the talk. So the link for this one is akka.ms/ragchat, and the demo that I just showed you here is available if you want to see a live version of that as well. So I'm going to kind of dig into now like how that is working and how RAG can be implemented. So kind of first off, I showed you database rows where you've got structured data in a database, and you need a way to be able to search across that database. You could do a keyword search, so you'd look at particular columns, for example, or you can do that based on the vectors and similarity, which we'll go into now. And then we've got unstructured data, which could be documents like manuals, PDFs, PowerPoint presentations, websites is a really big one. If you've got a huge knowledge index or you've got some information you want to pull online, and you want to index that and make it searchable and then make a chat interface that you can talk to and ask questions, then you're kind of looking at an unstructured data problem. So for both of these, you need to have, first of all, a sophisticated LLM. So you need to be able to give the LLM the information that you've retrieved and for it to be able to discern which things are relevant and which things are not. You have to have data that's pretty well prepared. If you've got documents which contradict each other, then it can kind of create confusing answers. And then lastly, you need a sort of powerful search functionality, because the key to effective RAG is being able to have good retrieval. So based on what the user has asked for, you need to find the most relevant information either from your documents, your database, or somewhere online. So that kind of search piece, which is the retrieval stage, needs to be as effective as possible in order for RAG to be effective. So to be able to do this, I mentioned fuzzy search, but really the term we're looking at is actually vector embeddings. An embedding is a way of representing some information as a series of numbers. There's another kind of diagram on the next slide that kind of shows you it as like a point in space. And the way these models work, so far we've talked about large language models or LLMs. An embedding model is a different type of model completely. Like they don't work like LLMs. What they've done is they've basically given it lots of bits of information, and then it can represent any piece of text as a series of numbers. And every time it does that, the width is always the same. So the number of numbers you get is always the same. But the reason you do it is because you give it 2 bits of information and it tells you how similar they are. So for example, we can encode the word dog. I could encode the word bloodhound. I have a border collie. That's the dog that I have downstairs. And if you ask them how similar are those things, it would say they are quite similar because they're all types of dog and the first word is dog. The reason this is important is because we can create vector embeddings not just on a single word, but on a paragraph or a sentence. And then we can say how similar are these 2 paragraphs. And where that comes together is you can take the similarity of what the user has asked for, what they're looking for, and the information that you have in your documents. The embedding models that typically are used for this, text embedding ADA002 is the classic OpenAI embedding model. This is actually the old model. The one we recommend you using now is either text embedding 3 small or large. They're much more accurate. They're a lot faster as well, and you can scale them down to a smaller vector size. If you're not working with text, if you're working with images, we've also got Azure Computer Vision and the Florence model, which can do similarities between pictures based on characteristics in the images. So when we talked about how similar things are, this is extremely difficult to imagine because this picture is 3 dimensions. But in the last slide, I mentioned that there's these models which work with 512 dimensions or even higher than that. It's impossible for you to picture. But basically, it represents a piece of data somewhere in a space, and you can take another piece of data and then measure the distance between the 2 points. And the further apart they are, the more dissimilar they are. The closer together they are, the more similar they are. So if you can have 2 sentences and you say how similar are these sentences based on lots of different characteristics, including the words in them and the meaning of the sentence, the different embedding models will give you a result which says how similar they are. So the trick with vector search is that we take the user's question, the user's input, we turn that into a series of numbers using an embedding model. And then we compare that with the information we already have, and we find the closest match. So when we had mountain trail shoe, instead of just doing a keyword search in the database to say mountain trail shoe, we could actually just say, okay, find me things which are like that, because they might have mountain hiking shoe or outdoor hiking shoe or outdoor hiking boot. So outdoor hiking boot is actually very similar to mountain trail shoe, even though the words are completely different, because they mean the same thing. And this is what vector search is really good at. So to kind of string that together, you've got the word tortoise. OpenAI can turn that into an embedding, which is a series of numbers. And then we can do a search in a database or in AI search and say, find me things which are like this, and it'll give you a result. To do this in Azure, we've got plenty of options. And this is one of those things which is changing week by week, so it's quite hard to keep up. You can do vectors, so you can store vectors and also do that sort of similarity query. In Cosmos, MongoDB vCore, you can do that in Postgres, you can do it in Microsoft Fabric, and Azure SQL Server this is done actually. This is not upcoming anymore. This is available already. And then AI search takes that same sort of capability, being able to do a search for similarity, but takes it a lot further. So it gives you the best sort of quality results out of the box. And the way that it does that is AI search is available as a service. And it effectively gives you an API where we take away a lot of the complexity of having to figure out how do you do the embedding calculation, as well as how do I create and split up my data into pieces where it can be searched. Azure AI Search gives you the capability to say, okay, here are my documents, here is my relational database, here's my SQL database, here's my data lake, for example, and it can then turn all of that into an index where you can do a vector search and a keyword search and plug it straight into a RAG solution. So the demo that I showed you before, which is this one, this is using Azure AI Search. And what we've done is we've given it these PDFs, and we've given it different documents. We've given it PowerPoint presentations, and we can ask it pretty much any questions in those documents, and it will come back with a knowledgeable answer, and it will give us these sort of citations to say where it found that information. So if you've ever wondered, like, how do we do that with Bing, or how is it done in other chatbots where it gives you these citations, it's effectively a RAG solution where we've combined the vector search capabilities and keyword search into a single process. So because of the technical issues I had, I'm going to be a bit selective about the things that I'm going to talk about. So there's different ways of doing that. When we talk about similarity, there are effectively two different ways of calculating similarity when you're looking for information in a database. That really comes back to how big the database is. If it's 10 documents and each one of them is less than 100 pages, for example, then you're only talking about, let's say, 10,000 paragraphs or bits of text. And if you're doing questions and Q&A on that, then an approximate search is probably pretty good because you don't want to filter out too much information because you might miss something that's important. If you're working with a huge data set, so you've got thousands of documents, or your database that you vectorize is like millions of rows or above, then really you kind of need to be a bit more strategic about how you filter out information before searching for it. So when we did the Postgres demo earlier on, the user asked a question that included like a filter saying, oh, less than $30. So instead of just doing the similarity of the text across everything, then you want to filter out that data first. And that's what we can do with a pre-search. We've also got the ability to kind of write those types of filters as a question, or to look for specific attributes in the vector index. We can also look at multiple fields per document. So if it's not just plain text, unstructured text, but we've actually got like an index. So for example, you've got products and you've got the product name, the product description, or you've got also like a picture of the product. If the customer, like the user, asked a question, a great blue stripy black backpack, if only the picture had that information, then you'd want to do a search that included the actual information that's embedded in the picture. So you wouldn't just go based on the description, because if the description doesn't mention that, you're really kind of looking across multiple fields. And Azure AI Search has got the capability to combine the information together and look across multiple things. And we've also got the ability to search different types of data. So I mentioned the embedding models. Those are all text models. From Microsoft as well, we've put together an image embedding model called Florence. And Azure AI Search can do searches across images, sounds, and importantly, graphs as well. This one comes up a lot with customers who've got sort of graphs in their documents which show financial data, or they show relationships with things, or they've got tables in documents which are actually stored in a PDF, and they're essentially a picture. They're not like a nice table that we can look at and grab data from and work with the data. So when we kind of started off this, I was talking about how the user could ask a question, and then we look for what they've asked for, found some relevant bits of information in our database, and we've taken that information, we've given it to the LLM, and we've given the LLM the question, and it's looked at the relevant data, and it's come back with a nice comprehensive answer. So there's two ways of doing that. One is you do a keyword search, which is where we took just the words they're looking for, and we do like just a traditional like text search in the database. And then the other approach is we do a vector search. We say, what's the most similar thing based on an embedding model to what the user has asked? Now I'm going to show you some pros and cons of both of those approaches. So if we took the example, what underwater activities can I do in the Bahamas? If you just did a keyword search, it would match on the word Bahamas. If you did a vector search, it would match on underwater activities, and it would also see the Bahamas as being a tropical place. It's a lovely place, nice place to go on holiday, but it would see that scuba diving in the Caribbean is very similar, and water skiing in the Seychelles is very similar. Now, the Seychelles is nowhere near the Bahamas, but it's also a tropical place, and water skiing is another thing you do and you get wet. So as far as the vector search is concerned, it is similar information. But if the user asked that question, what underwater activities can I do in the Bahamas, and your bot started talking about water skiing in the Seychelles, your user is going to get pretty annoyed because that's not what they asked for. But if you just go by relevance in a vector index using an embedding model, that second hit is actually probably is very similar. So the stage you have to basically introduce is you take the keyword search information and you take the similarity, like the vector search information, and you fuse them together using something called RRF. And that would essentially sort of move them around and zip them together. So we come back with, okay, scuba diving in the Caribbean, scuba diving in the Bahamas, and water skiing in the Seychelles. So it's kind of sort of half match those. It has also got it wrong. So because of the way that Fusion works, it doesn't know the information inside the message, inside the results. It will just kind of combine them together using a ranking. Now, what we've got in AI Search, which is unique to Azure AI Search, is we have an additional model that sits on top of that, which is able to look at the results, look at the original question, and then actually reorder the results and exclude things which is decided are not relevant. So water skiing in the Seychelles is decided as not relevant. Its score is not high enough, so it's excluded that result completely. If you just work on vector similarity, everything is a match. So if you go on a database of a million rows and you type in anything, and you did a vector search and say, show me everything that's similar, every single row is a match, but it's ordered from how similar they are to how dissimilar they are. Unlike keyword searches, where it's either a match or it isn't. The word either exists or it doesn't in that row. Vector searches are different. It just tells you the distance from the information you're looking for and the information that's in the database. So the re-ranking model is this extra step that we've got to add a couple of things. One is a score from 0 to 4, which tells you like how relevant that information is. So you can just exclude stuff which is not relevant at all. So don't even give it to the LLM if it's nothing to do with what the user asked for. This is really helpful when you don't have a load of information in your database, and you find that if you just did vector search, it kind of keeps hitting on things which are kind of similar but not really what you're looking for. The re-ranker algorithm in AI search is able to exclude that for you. To put that in sort of as a graph and show you like how does that actually compare, the orange bar is the semantic re-ranker. There's a blog post on this, the RAG relevance blog post, and that's at the link below. And that explains kind of a bit about how this algorithm works and how it was put together and by the engineers at Microsoft. And we've built that into Azure AI Search, and that's a feature that you can turn on. What it means in reality is that when you benchmark different data sets, so when we tested this against, there's some like open public data sets. The Bear one and the Miracle one are two common ones which are used. The Bear one is mostly in English. The Miracle one is a multi-language data set. If you benchmark either of those against the traditional approaches, the semantic re-ranker is much more effective. So it's able to find information and give you the right results. When we've actually shared that with customers as well, and we've looked at how customers are doing with the performance of that, they come back and unanimously said that adding the semantic re-ranker gives us more relevant information, and it's able to exclude stuff which is not relevant in the search. So far I've talked about the documents and how you can search across them in the RAG demo. But something else that's really important with RAG, when we were looking at so when you do a vector search, you take a string of text, you give it to an embedding model, and it gives you back a vector. And you give it another string of text, and you can compare the two things. You can also give an LLM a string of text. The amount of text you can give an LLM is actually quite limited. Current models are around 128,000 tokens, which is roughly like a few pages. If you give it 128,000 tokens and ask it lots of questions about what's in that message, it won't perform that well. The more information you give an LLM in a single hit, the worse it is at answering multiple bits of information, like looking at the question. So it drops off basically dramatically the more tokens you give in a single question. So this is a behavior that's exhibited in all LLMs. The newer ones have scaled better, but they still have this challenge. So what we do to get around this is we take a document like the PDF or like a huge description, and we break it down into smaller pieces called chunks. So depending on the type of document and depending on the model, we would recommend essentially splitting it up somewhere between 512 and 4,096 input tokens per vector. So that is, well, it depends on the language, but if that's just English, it's roughly 1 token per word. So 4,000 words is per like chunk is really the biggest we'd recommend. If you can get that smaller, so if you can get that down to 512, which is roughly like a couple of paragraphs, and that is how you split up a document into 2 paragraph pieces or 2 paragraph chunks, then your search is going to be a lot better and your retrieval and your responses can be much better. There's also a blog post at the bottom here. If you work with Chinese, Japanese, or Korean, I've got a blog post about how to handle those languages and how to do chunking and text splitting with them, because there's a whole bunch of really unique things about handling those, and Thai as well. That also applies with Thai. Cool. So I'm going to skip forward. Lost a bit of time at the beginning with the internet crashing. So the way that you have to ingest data to get it into a search index is you have to upload the documents. You have to get the information out of the PDFs, the web pages, the documents, PowerPoints, Excel spreadsheets, whatever they look like. You have to parse those into text. If you're using a text embedding model, you can't give it a binary file. So you can't just give the bits from a PDF or like HTML tags directly into a text embedding model. If you did that with HTML, most of the information is markup and it's not relevant to the vector index. So you basically need to prep that information and get it into just its text form. You then need to split it up into chunks. We've either got the code to be able to do that, so you can copy our code and our sort of recommendations, or you can use the integrated vectorization in Azure AI Search. Once you've done that, you need to vectorize the chunks and store the embeddings. And once you've stored the embeddings, you can put them into Azure AI Search and you can run your search across all that information. So those are kind of the steps and the stages. It is pretty involved. We've got a lot of information on how to do this. If you're working with PDFs in particular, they are very, very difficult document formats to work with. They're lovely. They look nice. It looks the same for everybody. They're a complete nightmare to process. So our recommendation with PDFs is that you use a combination of OCR and like binary reading. But Azure Document Intelligence has got that built in. So the reason I kind of mentioned Document Intelligence is because you can just give it a PDF and it can read that and tell you what text there is, what tables there are, what pictures there are, and it can just do the extraction for you. If you try and do that with some of the free open libraries that there are out there, they will struggle with some types of document depending on who produced it and how it is laid out. All of this is available built into Azure AI Search as well. So probably the easiest option with Azure AI Search is to use integrated vectorization, where you just point it at a blob storage account and say, we've got PDFs and documents in here, and it will go and read all those for you, it will chunk them for you, or vectorize them for you, and it will end up with an index. So that index will contain everything you've got, and you can just get going and search immediately over those documents. That also works on SQL databases and Cosmos databases. So you can just basically give it your data source, connect it up, say which Azure OpenAI account you're using to do the embeddings, and it will connect everything together for you and chunk it and piece it together. I think we are running out of time, so I'm going to skip forward. I'm going to skip evaluation. And I'm going to talk about securing your RAG just quickly, and then we've got time for a couple of questions. Everything I've showed you so far kind of assumes that every user should have access to the same information. Now, this is not always true, especially if you're doing like internal documents or policies or questions. Everything that's in the database can be searched by anyone if you follow the pattern that we've talked about so far. So we've got another demo, which is acco.ms/ragchat/ACL. And that one I've got running here. And it's basically the same as the demo that we've got here, except that when we ingested the documents, we've also said this PDF is only for employees in this org. This document is only for people who've got this particular permission in our directory. So if you're using Entra ID and you've got information about your users stored in Entra, or you're using another directory, then you can basically extend the behavior so that when the user asks a question, first of all, they have to log in. And then secondly, when they ask a question, it knows which parts of the search index they can see and which ones they can't see. So the relevance of the answer is based on the individual and not just the information in the database. And this is kind of one of the extensions that we've got. This shows me things from an employee handbook. And only employees are allowed to see that. So we've basically extended the functionality to include additional data based on who's logged in. And you can see all of that in the filter here. So I can see my my ID, and it's included that information from my login in the Azure AI Search. And we've got the code to be able to do that at that link on the right-hand side. And then finally, if your data is extremely sensitive and you want this to be completely isolated from the internet, you can deploy all of this in a virtual network and use subnets for isolation. So yeah, that's a really sort of whistle-stop tour into RAG. Some internal uses we've seen have been sort of public government data has been very effective, internal documents, customer support requests, and sort of call transcripts and call history has been really good for this type of approach. Technical documentation, product documentation, product manuals have been great as well. PwC have got a really interesting example of how they've scaled up a lot of their sort of enterprise data, and they've put this into a production system as well. So next steps, if you're interested in Azure AI Search, use the link there. If you want to understand the relevance algorithm and how that works, there is a link at acad.ms/rag relevance. The RAG chat application with your data is there. That is written in Python, but we've got equivalent demos written in Java, JavaScript, and C# as well. And then if you want to explore different models and how they perform with RAG, you can see that in the AI Studio. And we've got some more resources for you as well if you want to grab a screenshot of these links. So you can come back to them later. And then I'm going to hand back over to Priyanka and then or Michael. And if you have any feedback from today's session, sorry, apologies for the technical issue at the beginning. But yeah, my internet dropped out for no apparent reason. So hopefully we got through everything we could. Thank you.
Thank you, Anthony. We would absolutely appreciate your feedback, and especially on the content of the session, obviously. But you know, we are in the process of making this series as effective as possible for all of you. So your feedback is extremely important. Please do drop whatever feedback you have using this form. And then let's go to the last slide, which is the registration page. So if you haven't already done it, I mentioned it in the beginning as well. We have 4 more of these sessions coming up, and there's lots of amazing stuff that we've planned for you. We'd love for you to join us and utilize all these amazing free resources to learn and to upskill in AI. Here's the QR code to register for all the rest of the series that we have planned here. And I also encourage you to make sure, because we are not sharing the last session yet, because we would love for you to join us in each of these sessions so that you're learning and taking this journey with us. The entire idea of the series is to get this cohort-based experience so that we all learn together and ask our questions together. And so based on that, we'd love for you to join every single episode. We do understand if you have something else going on at the time, these are also available on demand. So I still highly encourage you to register so that you are notified of the times and know exactly when these are happening, and are able to make it. And then I do look forward to seeing you all getting this all in action at the very last episode after the 4th of March. And here's your link to the badge as well. You scan the QR code and download the badge and add it to your LinkedIn profile once you get certified. So we're really, really excited to help you be on this AI journey, and we're excited to learn from you in terms of what you are building. With that, I will close it out. Thank you so much for joining, and I apologize for the technical difficulties, but hopefully you enjoyed hearing me in the meantime, which I definitely enjoyed. So thank you very much, and we'll see you next time. Bye.